So hello everyone. Can you guys hear me? Can you guys see the screen as well?
Yes, yes.
All right. So this is the Team 15 Spring 2023 for the SER502 subject. We were given the task of creating a programming language. The programming language for the name of the language for our group is Phoenix, and the team members are the first one is me, Heath Punjawat, and you guys can.
Next, hi, hello everyone. My name is Shivanjay.
Hi everyone, I'm Janki.
Hi, I'm Manan.
Hey guys, I'm Okapisa.
Hello. So all right. So this is the presentation that we have made. And first, this is the flow that we are going to follow throughout the presentation. First, we'll discuss about the language, what it is, the design that we followed, the grammar that we made for the language, and some code snapshots as well. So about the language, the name of the language is Phoenix. The file extension for the language is .phx that we have created. It is an imperative programming paradigm, and so for the Lexa we have created, we have used Python to create the Lexa, and we are using Prolog to create the parser and the evaluator as well. So the next thing is design, and this is the design flow and the project pipeline. If Janki wants to explain about this.
So the design we are following is, first we need to create the PHX program file you need to execute. So this PHX file will be an input to this lexical analyzer. So lexical analyzer will extract the tokens from that and generate the another file named PHX tokens. So it will separate the tokens, and this token file will be supplied to the parser, and the parser will generate the parse tree. And this parse tree will serve as an input to this interpreter, an evaluator, and this evaluator will generate the output. And here we go with this project pipeline. So this PHX file will be given to the lexa.py, and this py file, this lexa will generate the PHX tokens, and the tokens will be given to the parser, and we'll get the output through the evaluator.
All right, looks good. So just explaining all the components of the design that we have used here. So the program is basically written in PHX that we just discussed. The flow also Janki just discussed about it. Omkar worked on the lexical analyzer part. So can you explain about it, please? Something, please, Omkar.
Yeah, sure. So basically, lexical analyzer, also known as lexer or scanner, it is a component of compiler or like interpreter that takes input source code and it breaks it down into individual tokens for further processing. Also, the lexical analyzer identifies and recognizes the lexical patterns in the input source code and generates a stream of tokens that are passed to the parser for like syntactic or like semantic analysis. And the tokens produced by the lexer can include keywords and identifiers, operators, literals, as well as language specific constructs.
Okay,
That
so
was
the next thing is parser. Shivanjay, can you explain something about it?
Yes, so a parser is a tool that reads the code and checks whether it follows the syntax and the grammar rules of the programming language. And it does this by breaking down the code into smaller components, and these smaller components we call them as tokens. And then it organizes these tokens into a hierarchical structure, which we call it as a parse tree. The parse tree basically represents the program's structure and shows how the different parts of the code are related to each other. Uh, it can also serve as a way for the parser to identify any syntax errors in the code. The parser uses a set of predefined rules, and we call these rules as grammar. We use this grammar to build the parse tree. The grammar basically specifies the syntax and structure of the programming language, and this includes rules for the order and combination of statements, etc. How the variables are used, how the data types are used, and the use of control structures such as loops and other conditional statements. And once the parser has built the parse tree, it can check whether the code conforms to the language's grammar rules. If the code contains or has any syntax errors, the parser can generate the error message accordingly.
Okay. So the next is evaluator or the interpreter that we have created here. Manan, can you please explain something about it?
Sure, yes. So the parse tree that was created with the help of the parser is used by the evaluator essentially as a blueprint to carry out all the relevant set of instructions. And the evaluator is in charge of analyzing the parse tree and carrying out the required calculations according to its layout. It's a crucial element of the compiler or the interpreter that helps with the transformation of the code from human readable to machine executable format. And the parse tree, which was created by the parser, acts as a link between the parser and the execution state. And it's a crucial element that directs the evaluator's decision making.
Okay, that's good. So the features that our programming language Phoenix supports are here as follows. Shivanja, can you just tell us something about these features?
Yeah, sure. So for the commands, we have a for loop, we have a while loop, we also have an enhanced for loop, and we have the if loop, if else loop, if else loop, and other than that, you can also print, and we have variable declaration. You can also assign values to these variables, so we have variable assignment as well. And there are some rules for variable naming. These are very simple rules, like the first letter has to be a lowercase letter. And other than that, the other characters can be lowercase or uppercase, and also you can use underscores for variables. The data types we are currently supporting are, we have integer, we have float point number, we have string, and we have boolean. And for the operations, we have arithmetic operations like addition, subtraction, multiplication, division, braces, and ternary operators. And yeah, and these are some of the reserved keywords. These includes like false, true, and bool, elif, else, float, for, and if, int, etc. Like as you can see on the slide.
All right, looks good. So the next part is grammar. So all of the features that Shivanja just talked about here. So we had to define like what we need to use and what the language is going to support. So all of that we defined in the grammar right before we start, before at the beginning stages of the project. So the grammar is basically something that defines the syntax rules for the programming language. And over here we have divided the grammar in two parts, in terminals and non-terminals. So the terminal section defines the building blocks of the programming language, which includes all the keywords and the operators and the punctuation marks and how and like exactly how they should be used in the .phx file in a specific format. And the non-terminal section defines the language syntax rules for using these terminals as building blocks. So that's all about, I think, the grammar. All the features, basically, they are Shivanja just explained about all of these. So you can just look over. We have the elif clauses, we have the while loop statements. So how the while loop should be executed. We should use the while, write the while first, and then open and closing bracket, and inside should be the condition. So it basically defines how to write the code for the .phx file. So this is still the grammar part going on. All right. So for the code snapshots, this is basically just a snapshot. We are also going to display exactly how to run and download the code from the GitHub repo as well. So you can just look through this after this. Basically, the code screenshots, I'll just run the code quickly as well on how to do it. So this is the GitHub repo that we are using, SER502-Spring2023-Team15. This is the main branch that we have. Everything's up to date as of now. This is the code. You can directly just clone. You can select the directory in the terminal and then clone it there, or you can download the entire zip file as well. We are going to use the download feature over here. After this, downloads, here it is. Unzip it. After that, all right. So I'm using VS Code over here. You can use any other editor of your preference. So just open this code over here. And we also have to run all of the code, all the basically data files that we are running, all the .phx files, they should be inside the source folder, not anywhere else. So that's just another disclaimer. So here's the document folder, which has all the contribution.txt that we have for the milestone 1 and milestone 2. We have the first PDF that we submitted during the milestone 1, and we have the second presentation PDF that we need for the submission of milestone 2. All right, so here's all the files. We have the grammar that we wrote for over here, that we just explained. We have the main file as well. We have the parser, we have a lexer, we have an evaluator, and we have a token reader. So and these are all the data files, the .phx files that we need to run the codes on. So the first is lexer. I think lexer, if Omkar, I think just discuss about it. So these are all the same things. We have all the tokens that we used, that we imported from the SLY library in Python. And
Yeah, sure, I can give
if you
a
want to
quick
go ahead.
overview of the file. Sure. So basically, like, this is a Python script that will implement a lexer for the Phoenix programming language. The lexer is based on the SLY library, and it defines various token patterns and ignore patterns to identify and tokenize different construct in the Phoenix language. Basically the script takes a Phoenix source code file as input, and it generates a list of tokens based on the lexer implementation, and writes the token as a separate file with .phx tokens extension. Also, the script includes option to evaluate and generate tokens using SWI Prolog interpreter. There is also this rparse module, which is used to parse command line arguments for the input file name and the evaluation option. And finally, the script also defines some constants for color, text, output, and file extensions. So yeah, that was the basic overview of this lexer.py file, which I have worked on.
All right. So for the token reader, can Janki please explain something about it?
Yeah, please. Basically, it reads a file and converts its content to the list of items or numbers. So this will first open the file to read, and it will create a stream object, and this entire stream will be converted into the character codes. And after doing that, the stream will be closed, and this read stream function that will read a stream of characters and convert each line into this items. And this task will be done recursively until it reaches to the end of line, to the end of file. And this convert function, it converts a list of atoms to a list of numbers, if possible. And this current element can be converted into number using this first function. Yeah, that's pretty much it.
All right. So there's another main.pl file. If Shivanji can explain something about it.
Yes. So the main file, it imports like 3 modules. The modules are token reader, parser, and evaluator, and it then defines the main function. It takes a file name as an input. So, and inside the main function, the code reads in the contents of the file using the read file predicate from the token reader module, and then it uses the program predicate from the parser module to parse the code and generate a parse tree. And after that, it just outputs a message indicating that the parse tree has been generated successfully. And it then calls the eval program predicate from the evaluator module to evaluate the parse tree, and so that we can produce a result from it.
Okay, looks good. So there's another evaluator. If Manan, can you explain something about it?
Yeah, sure. So this program receives an input in the form of a parse tree, and then it executes it. The main predicate is the eval_program, and which takes the syntax tree representing the program and returns the environment after executing it. And there are different predicates as well. The program is divided into several types of statements, each of which is handled by a specific predicate. For example, the evaluator com_list is responsible for handling list of statements, and evaluator com is responsible for handling individual statements. And so the program supports several types of statements, such as variable declarations, assignment, print statements, loops, for and while, and conditional statements. It also supports some basic arithmetic and logical operations, such as addition, subtraction, multiplication, and overall, this program implements a basic interpreter for this programming language.
All right, looks good. I think we have discussed everything that we needed to for the explanation of code as well. So let's just run it. I think that's the last part of this presentation. So, all right, just change the directory to this source folder that we have, and press enter. All right, after we are in the source folder. So we are trying to run the test print.phx file here. All right, so this is the code lexer.py, evaluate test print. All right, so the lexer is running, source code scanning, everything is good. It's going to generate a pass tree just like this one. And we have the outputs over here, hello world, and this is SER502-Spring2023-Team15. So similarly, we'll be running all the other test cases as well. So we have this one over here. So we have for the while loop, and so it should print out integer I equals to 1, I less than 5, and there is an increase of I in just so that's how the 1, 2, 3, 4 will be printed, and this is the pass tree generated. So the next one is a basic for loop, and yep, test basic for loop.phx. So the for loop we have for this condition, this is the correct output, and yeah, the next one after the for loop we have enhanced nesting. So this is the one for the enhanced nesting. Here's the answer, and for the final one, test final.phx. All right, so here's everything. All right, so the print statements, testing print statements. Now this should print out testing print statements. This should print out the number 5. They should print out the answer for Z according to these calculations. And here's all everything that else we need. And here's the output. So here it is. So success. Here's the entire pass tree generated, and testing print statements. Here are all the answers for this file. So just one last thing you'll notice, that all the tokens are being generated. Another file is being generated under the same name but with the different extension .phx tokens. So for this for loop over here, so all of these are basically separated as single tokens. So this is exactly what we are passing in the pass tree, and this is happening for all the files that we are running. So this is the test.phx. Here are the tokens, and I think that was a demo. We'll add this link. We'll add the link for this inside the readme.md file as well for the YouTube video. And I think, is that it? Anything else from you guys?
Oh, this is it.
All right.
Nothing from my side.
Thank you guys for watching. Yeah.
Thank you.
Thank you, everyone.